So this is very exciting. This is the first video tutorial I'm making on our tuning system for the KTM 1290 Super Duke / Super Adventure and so on. Basically, this tutorial will cover any 1290, even 1090 and 1190 engine mapping because they all use the same Keihin ECU type. So the ECU structure is very similar, the mapping layout's very similar, and so on. So again, this tutorial is not really intended for the vast majority of OpenFlash tablet users. It's just for those who want to have gain a deeper insight in how the ECU works and how clever it is and what we can do to improve upon engine performance. The takeaway at the end of this video will probably be, holy shit, power commanders are toys and they should not be used on a modern ECU. And let's move forward. So what I have opened right now, let me start from scratch here. So first thing we do is fire up Tuner Pro. Tuner Pro is our tuning interface that we use. It's not ours, it's actually freeware designed by some gentleman, and you can download it at tunerpro.com. And let's open it up. All right, when this thing opens up, it's a blank screen. Two files need to be opened up in order to view and edit table data. One is the actual tune file, the binary file that we email out to people. The other is the definition file, which we also email out upon request. The definition file is basically a file that works with the binary file or with the tune file, and it exposes all the tables. So first thing we do is let's open up a tune file. Let's start off with, let's say, the Akrapovic tune file for a Gen 2 Super Duke. That's opened, you can see right there, but no tables. So now we open up the XDF file, the definition file, which is going to be here. Gen 2 OpenFlash 1290 SDR user 4. That's what I also email to people upon request. Double click on that, and here's all the tune files. Here's all the tables. Let's make it easier. Let's use categories. Okay. So we're going to start off with, we'll go top to bottom. First is alpha N. Now, again, this is not, if you don't understand this, that is totally fine. You know, any competent tuner will know this information. If they do not, they are not competent tuners. They are just people who want to sell you a power commander, hook it up the way they know how to hook it up, the way they've been taught, stick an O2 sensor in your tailpipe, which reads the average of both cylinders, which is ridiculous. And they'll press some plus or minus buttons. They'll run the auto-tune scheme, and they'll say it's done. They'll charge you, $500, $600 for the power commander, another $100 for the tune, and they'll say you're custom tuned, and you are not. And let's move forward. First is called alpha N fuel. Now, there's two types of fuel control. One is called alpha N. One is called speed density. Now, alpha N it's a fancy term for throttle based. So in other words, it's RPM versus throttle. Speed density is a fancy word for manifold pressure based. It is RPM versus manifold pressure. Now, most bikes, including the KTM 1290s, 1190s, and 1090s, they run speed density. This thing down here, let's look at a table. They run speed density mode at let's say below 3,000 RPM and light throttle. And then they transition over to alpha N, throttle based, above 3,000 RPM and higher throttle. So for the purpose of tuning, we almost don't have to touch any of the speed density stuff because it's only at low RPM, light throttle. So let's just close that, and we're just going to focus on alpha N our alpha N fueling tables. So let's do something fun. Let's start at sport. And as you can see, there are different fuel tables. So again, we're going to ignore speed density. Let's just ignore that for now. Chances are, unless you have a really unique build with high overlap cams, a really strange assortment of mods. You really don't need to touch this stuff down here. So let's just stick with this. So let's start off with, let's say, street mode, okay? You can see we have tables for the front cylinder and rear cylinder. And again, that applies for all our modes, all our riding modes. Pretty cool. All right, and in front cylinders, you have, it's separated by gearing. You have the front cylinder in rain mode, neutral map, neutral gear, fuel table. And then you have a fuel table for gears 1, 2, and 3. Then you have fuel for gears 4, 5, 6. Sounds complicated, but if you look, they're the same. They're really not any different. And to read a fuel table, you see RPM on this axis, and you see throttle on this axis. 100% throttle, 0% throttle, 0 RPM, 11,000 RPM. Applies to all the tables. So let's just look at one and try to get a better understanding. So you see as throttle goes up, fuel output goes up. These numbers represent injector on time. It's a general, it's kind of arbitrary factor. You can ignore what it represents. You just know that the larger number is more fuel output, lower number, smaller fuel output. So as throttle goes up, so does fueling. You can look at it as a 3D graph if you want to as well. So you can see here, RPM or TPS, throttle, 0 to 100. RPM, 0 to 11,000. You can see, whoa, more fuel. So let's close that. So you'll notice that in every single mode, rain, street, sport, track, fueling is pretty much identical, right? You can see the topmost 100% row, the same. The lower rows, the same. So we're basically a KTM provided a lot of tuning flexibility in this ECU, but really not using all the flexibility it has, because again, they want to produce a bike which runs right, not necessarily tuned to the nth degree, and they want to make it happy, and they want to make it work, and they don't want to deal with, you know, any kind of strange aberrant behavior. So this is the fuel table. So let's say you want to make you do a dyno pull and you're running lean above 8,000 RPM, right? So you go to 8,000 RPM, which is right here. And let's say you're running lean from 8,000 RPM to 11,000 RPM. You basically adjust, select here. You can go to, you can increase everything by 50 fuel units, and boom. Now I'm going to run a little bit richer. You'll notice now that you can smoothen this out by maybe adding 20%, 25% there. Or not 25%, 25 fuel units there. And that'll kind of eliminate that step. Let's look at a more extreme example. Let's say you want to add 800 800 fuel units, right? Boom. Now there's a big step. It goes from 87 to 97. So let's look at here. And here you can see you can even see the step. Where is the step? Up. Sorry, I'm trying to do this while looking at a screen. And you can see the big step we made here, right? At 8,000 RPM or 7,000 RPM. So we can smoothen that a little bit, smoothen that out. So again, the interface is very useful. You can see that smoothened out nicely. It's very graphic intensive, so you don't have to really worry so much about numbers. You just look at the shape of the fuel curve, and then you can start smoothing things out. So once you make a change there, this is again only a change for gears 1, 2, and 3. You can do the same. You can apply the same offsets you made, the same edits you made to gears in neutral, to gears 4, 5, 6, and you can do the same thing to all your other modes. Conversely, if you want to, let's say, actually make your sport mode more aggressive, you can do that. It's just right now in the stock tune file, what separates sport, street, and track is just throttle mapping. The fueling's all the same, the timing values are all the same, just throttle mapping. Well, you could go in there and actually say, listen, I want my only tuned mode to be sport mode, right? You can keep all these modes stock and say, when I click on sport mode, I not only want my sport throttle mapping to be more aggressive, but I actually want the fuel and timing maps to be more aggressive. So you have that option too. Again, completely unnecessary to take advantage of these options, but they're there in case you need them. So we kind of got a handle on how fuel works, right? Again, this is any competent tuner who's watching this video should understand what this is and how it works. But one caveat: you have your front cylinder and rear cylinder. The question is, how do you tune each individual one? A lot of tuners, you'll find them just sticking a wideband O2 sensor in the tailpipe. And the problem with that is it measures the average of both cylinders. And that really doesn't give you an accurate, useful information on how to tune a single cylinder. And that's the key of making power on any V-twin. Your front and rear cylinders, any Harley tuner knows this. Your front and rear cylinders are mapped completely differently. The front cylinder often runs cooler because it has air directly going past it. The rear cylinder runs hotter because it's more physically constricted. As a result, the front cylinder usually runs a little bit leaner, rear cylinder runs a little bit richer, and therefore you can extract more power by kind of equalizing them within reason, of course. So, you have to be able to measure the front cylinder accurately. For that, we use something called exhaust extraction kits. And instead of just sticking a wideband in the tailpipe, which again reads the average of both cylinders, we can read cylinders individually by measuring air fuel directly on each individual runner, really near the engine, really near the exhaust port. Because again, if we measure at the tailpipe, you could have one cylinder running super lean, one cylinder running super rich. You average them out, the reading is just perfect. And that's the mistake a lot of tuners make. So these exhaust extraction kits are really cool. But basically, you drill a small little hole in a runner. You press in this little threaded riv nut. You temporarily screw in a little metal adapter, which then you screw your wideband O2 sensor into. So it reads individually each cylinder, and then you can tune each cylinder individually, and you'll find you can pick up 5% more power by tuning each cylinder individually versus just doing the gross kind of average cylinder tuning method, which a lot of people kind of do. So again, the most important thing with tuning is making sure you have the right information, and you need to monitor AFR individually per cylinder. Good thing is, it's only a twin, right? It's only 2 times you got to do that. Imagine tuning a 4-cylinder like we do, like our V4, Aprilia V4s, Ducati V4s. We have to basically tune each of the 4 cylinders individually. That takes 4 times as long, but it results in a proper tune. So let's go back to this. So we have the idea of how fueling works, right? Don't need to make those changes. Ignition timing, same thing. We have ignition timing tables for all the different riding modes: track, street, sport, rain. And you can have ignition tables for the front cylinder and the rear cylinder. Very cool. And if you know, the LC8 engine has 2 spark plugs, 2 ignition coils. One is a trailing coil, one is a leading coil. Let's call that coil 1 and coil 2. Let's look at 4 through 6 gear cylinder 2. Let's not look at rain, because rain is kind of lower powered. Let's look at sport. Here we go. Gears 2 through 3, cylinder 2. And you have coil 1 and coil 2. You'll notice they're very similar, except coil 2, the trailing coil, has some ignition retard to high RPM. Once again, this is engine load, and this is RPM. As load goes up, typically any tuner will know that ignition advance goes down. As RPM goes up, any tuner will know that ignition advance kind of goes up. So you have this kind of shape where numbers decrease this way and increase this way. So you'll find that on the stock map, the ignition advance on the trailing coil looks kind of similar up to about 7,000 RPM, but then it starts to fall. That's because it's for emissions purposes. They want the second coil to kind of be kind of have cleanup duty, have a very delayed spark to kind of reignite anything that didn't ignite on the first spark. Very simple. So that's how that works. Again, you have it for all different modes, both cylinders, not just both cylinders, but both coils on each cylinder. Very cool stuff. At the end of this little bit, after I go through the basic breakdown of how these tables work, I'll show you how we tune them. So again, so we got an idea of ignition timing. Fly-by-wire throttle. Since these bikes don't actually have a cable connecting your throttle twist to the throttle bodies, it's controlled by a wire, by a signal, so we call it fly-by-wire. Again, you have them for rain, street, sport, and track. Okay? Neutral, table, gear 1, gear 2, 3, gear 4, 5, 6. Again, you'll see they're all very similar in the same riding mode, right? They're all actually identical. But you'll see that in rain mode, what's the maximum throttle? Again, this is the numbers inside are the throttle opening, right? Maximum throttle at full throttle, full applied TPS, 100% applied throttle. Maximum throttle opening is 59, 73, 68, 65. It's not very high. It's not 100%. But if you go to sport mode, boom, 100%. That's the difference. You'll see that it allows full throttle from 2500 RPM on up. Below that, you'll see it does not allow full throttle. You ask why? Well, engines are kind of funny things. At low RPM, a lot of these high revving engines, which this essentially is a high revving engine, it's not like a car, right? Which only revs to 6,000, 7,000 RPM. At low RPM on a motorcycle engine, it's found that keeping the throttle slightly closed at low RPM actually helps power because it introduces a tumble and a swirl of the air into the cylinder. That improves air-fuel mixing, homogenization, and power. So at high RPMs, you don't need to have that tumble because just the mass of the air going into the engine is good enough to generate that tumble. So by 2500 RPM, full throttle, good to go. Let's compare sport mapping to, let's say, street mapping. Here we go. A couple things you notice, right? They are different. If you look at sport mapping, let's say at 35% applied throttle versus 35% applied throttle, street mapping, it only opens up throttle about 15.6%. Sport mapping, it opens up almost 18%. So you see it's more responsive to throttle. And you can see that difference apply everywhere for the most part, especially at 29%. Sport mapping, 11% open throttle, only 9% open throttle. So that's why you find on sport mapping, it's generally more aggressive, more touchy, more responsive. You'd be surprised, not a really huge difference, but it's enough to feel. Oh, good example here. 68% throttle. Sport mapping opens up 54%. 68% throttle and street mapping, it opens up 44%, 40, 45, 46%. Pretty big difference. So that gives you an idea. Next up, limiters. Rev limiters, right? Pretty straightforward. This is the rev limiter per gear. I'm not sure, I haven't bothered really testing which rev limiter which gear this rev limiter applies to, which this applies to. It's kind of not really important to me. I usually set the same rev limiter for all the different gears. This number and the smaller number in the middle, that's actually hysteresis. That defines how much bounce there is once you hit the rev limiter, whether it goes bam, 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 or ba 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 ba, right? So again, I usually leave this stuff stock. I tend to not increase rev limiters too much because usually this engine makes peak power well below the rev limiter. So if you increase the rev limiter from 10,000 RPM to 12,000 RPM, you're not really making more power, you're just increasing the stress in the engine. So be reasonable there. And that's it. Of course, the exhaust valve mapping, servo mapping. Most exhausts eliminate this exhaust valve, so it's not even relevant, but it's there in case you want to see it. As throttle goes up, exhaust valve starts to open. As RPM goes up, exhaust valve starts to open. Pretty cool stuff. You could use this on a stock bike with a stock exhaust to kind of tune in how loud you want the bike to be. Pretty cool stuff. So we kind of went over the basic mapping. Now I'm going to load up one of my tunes. Let's load up our stage 3 tune. in a comparison file, right? So let's go to alpha N mapping. Let's go to sport, front cylinder, gear 4, 5, 6. And to switch back and forth, you see I'm loaded there as my comparison file. I can switch back and forth just by hitting this little balance, and it shows the differences here. So if this is the Akrapovic tune, that's my tune. And you can see the differences by clicking on this little sign, this delta sign. Boom. You'll see compared to my Akrapovic file, the stock tune file, compared to my stage 3 file, the Akrapovic file has way less fuel output, from 3,000 RPM all the way to 11,000 RPM. That's because our stage 3 files is designed for shorter velocity stacks, airbox, full exhaust, cat lead, etc. And all that stuff requires more fuel to maintain the same air-fuel ratio, right? More fuel goes in, more air goes in, you got to get more fuel in there at the same time. So you'll see pretty big differences. Ignition timing now. These bikes love ignition timing to a degree. Like every engine, you can go too far and induce knock and hold pistons and do nasty stuff. Don't do that. Okay. The key for tuning ignition timing is to stop when the engine stops making power or when you start hearing audible knock. Fortunately for this engine, it'll stop making power, a little bit before the time it starts to audibly knock. So you don't have to run right to the ragged edge and make that judgment call yourself. You can start increasing timing gradually, 1 degree at a time, see the improvements on the dyno, and if it stops making an improvement with an incremental degree, take the degree out. Don't leave it in there. That's just going to add extra stress on your rods, your piston, reduce your safety margin against detonation. So any tuner should know this, should be very reasonable. Again, so let's look at coil 1, sport mode, gear 4 through 6. As throttle goes up, ignition timing goes down, right? So you'll see, let's compare to my tune, my stage 3 tune. Actually, not a lot of difference, right? You'll see the stock tune, so the Akrapovic tune has a degree more timing down here, right? But it has a degree less timing up here, in kind of little weird places all over the place, right? You'll see my stage 3 tune has more timing, kind of a degree more timing, almost this whole region here. That's because the VE of the motor the volumetric efficiency of the motor has changed with the shorter velocity stacks. Shorter velocity stacks trade low end torque. Generally, it's not that much. It's almost unmeasurable on the dyno, interestingly enough, but technically it does. And in exchange for more top end power. And let's see, what's next? Oh, coil 2. You'll see that coil 2 on the Akrapovic tune, it just drops ignition timing up here. My tune keeps it. I don't care so much about emissions, about clean burn. I just want to make sure that we have both coils firing, at the right time together to make sure that burn is as quick and as efficient and complete as possible. So if you do a comparison here, you'll see a pretty big difference between the Akrapovic tune and our stage 3 tune. You'll also notice that our stage 3 tune, coil 1 and coil 2, pretty darn similar. Actually, they are similar. They're identical. So even though the difference is huge on coil 2, it kind of mirrors a coil 1. Next, let's get rid of ignition timing. Fly-by-wire. Again, you don't really need to make much changes here unless you feel that you could, opening up the throttle a little bit earlier down here, allowing for more throttle at low RPM, increases power. I've tested that. It doesn't. The KTM kind of nailed this pretty well. You don't need to, increase the throttle, maximum throttle at low RPM. If you do, it doesn't really make any more power. Actually, it can lose power. But if you wanted to, you can make your rain mode a little bit more aggressive, or in matter of fact, you can make your rain mode an actual performance mode. You can make it. You could copy and paste your sport mode tables on like this, like the whole thing. Copy, put it here, paste. There. I copied and pasted the entire sport mode table onto the rain table. This gives you an idea of how to kind of transfer mapping from table to table and make any particular table what you want it to be. So close that. And lastly, Rev Limiters. I don't think I changed them, do I? No, I don't change it at all for our stage 3 tune. Now, a lot of tuners can raise Rev Limiters on the 1290 engine. I've had people, I know people I trust who raised them as much as 500 to 1,000 RPM without grenading anything or breaking rods or spitting out pistons. But my philosophy is, if you don't make power up there, why rev it up that high? Yeah, it's cool. It gives it a little more revs to play with. But again, tuning is always a balance between margin of safety and power output. If you're not going to make power output, making a change, don't make it. And that pretty much sums up everything. I'm sure there'll be some more questions, and I'll be happy to answer and maybe make a second revision of this video. But for now, that kind of gives a quick and general synopsis on how to use this software. And hopefully any competent tuner will look at this and go, oh, it's very simple. It's like tuning a car. It's got all the same tables available to you, and you just have to apply a very you just have to have a good methodology when tuning this stuff. Again, it does take a little bit more time than a power commander, because power commanders, you're really just kind of tuning fueling offsets based upon, the underlying tables, which you don't really know what they are. So you're also having to fight the closed loop fuel control system by installing silly things like fueling dongles, which eliminate the actual ECU fuel learning capability of the, which is ridiculous. But again, a lot of people don't understand that, and they realize that they can't get a power commander to work unless they start making, eliminating sensors, like functional sensors like O2 sensor, probably the most important sensor in the bike. So hopefully this video kind of draws light on how important it is to tune properly, to take advantage of how clever the stock ECU is, and just tweak it to make it do what you want to do, not dumb it down and install a stupid device and then start making arbitrary fuel and timing changes on top of an ever-moving foundation. So that's it for me. I'll be happy to, again, make more edits to this video or make a version 2 based upon feedback I get from the forum. But hopefully this covers most bases and gets people understanding what we do. Thank you.